Alright guys, so this video I'll be going through the completion of squares. So basically completion of squares is just a method to solve a quadratic equation. So there are different methods in which you could use to solve the quadratic. This is just one of the methods. The method is called the completion of squares method. The other methods are like the quadratic formula, and you could use factorization to solve it, right? So you have to remember, when you solve a quadratic, you basically get the x-intercepts. So if I was to sketch a quadratic, remember quadratic is just a curve. When you solve a quadratic, you basically get in these points here, the points at which it cuts the x-axis. So there's the x-axis here, and there's the y-axis. So you have to remember, when you solve a quadratic, you basically solving for the x-intercepts. Alright? So you'll normally get two x-intercepts. Alright? So remember, when you solve it, yeah, and then I put these points. I always remember that, right? So the form of a quadratic, by just looking at it, basically a quadratic is where the highest power of x is 2. So if you look at this here, power is 2. And in the equation, there's the highest power of x that you have. If it had an x to the power 3, then it wouldn't be a quadratic. It would be a cubic, and so on, right? So in a quadratic, the form of it is a x squared plus bx plus c. You need to pay attention to a, b, and c. Yeah, because you need to use those stuff in the completion of squares method, right? So always remember, the form of a quadratic is ax squared plus bx plus c. That's one thing you need to remember. Ax squared plus bx plus c. Remember this. This is one thing you need to remember before we start this. Alright, so take some time and remember that. Alright, so let's start this one. So when you're doing this one now, the completion of squares, this is the formula you need to remember. Alright, is a open bracket x minus h squared plus k. Make sure you remember this. Yeah? And it's fairly simple once you remember. You could use this equation to get certain element from it, right? The first thing is a, second thing you have is h, or the third thing you have is k, right? A is the easiest thing because you could just get a from the equation itself. So this a here is basically this a here. So like say I had 2x squared plus 4x plus 7. This, the a here, would be this a here also. Yeah? So a is the easiest thing to get, which is 1. 2 and 3, you have to use a little equation, right? So how 2 and 3, h is called the axis of symmetry, right? So think of axis of symmetry as the line that cuts the quadratic equation in half. So if you draw a quadratic here, the axis of symmetry does be a line that cuts it in half. Yeah, it literally looks symmetric on both sides. Pretty cool. That's the line of symmetry is, and that line of symmetry is at x-intercept because the x-axis, right? So when you're given it, you'll normally give it as x is equal to h. Yeah, so I'll do an example with these. Just remember this one. So that is the axis of symmetry. H is called the axis of symmetry. K, however, is called the maximum minimum value. Yep, so the maximum minimum value, think of it as the lowest. In this case, it would be lowest. Or if I drew it in another direction like this, it will be the highest. Yeah, come on, we'll be going up. So this will be highest when you come back down. If you're doing like this now, you're going down. So this will be a minimum, and then you go back up. Yeah, so it depends on how they drew the graph. So, and each graph will either have a maximum or a minimum. If you're going down to a minimum. If you're going up to a maximum. Yeah, so that is, and there's a y value. So I have the equation y is equal to k. Yeah, and when you put these two things together, h and k, like this, you'll get something called the coordinates of the minimum or maximum point. Or normally, let's say the turning point. Yeah, it's basically just the point that it turns, it's like changes direction. So this point here is the turning point. Why? Because the point at which you start to go downwards. This point here is the turning point. It's just the point that you start to go upwards. Right? When you combine the axis and the minimum point, you get the turning point or the maximum minimum point. Yeah? So the equations I need to remember for h and k. H is minus b on 2a. So remember, you get b and a from the quadratic equation itself. And then k is f of h. Yeah, there's some method you could use. Or the second method is you just using the equation and plugging in the values. So k would just be 4ac minus b squared on 4a. Alright, just pick one, both methods will work comfortably. And once you have K and H, and well, obviously you'll have A, you'll just plug it back into this equation here, and that'll be the form of the equation in the completion of squared form. Yeah, very simple. Just need to remember obviously the first thing you need to know is this, because you need to know what A, B, and C is. You'll get A, B, and C from this equation. They will give you this equation. Second thing, you need to know this, X minus A squared plus K. If that asks for the axis of symmetry, you know where it is. The minimum and maximum point, you know where it is. If that asks for the coordinates of the maximum in or the turning point, you just combine H and K to form a coordinate. The equation for H is minus B and 2A, and K is f of H, or K is equal to 4AC minus B squared and 4A. This method, nice. This depends on which method you like. Alright, both methods will give you the same answer. Alright, so that's a show you some stuff. So if you have this graph here, this point here is the turning point. Yeah? Why is it the turning point? Because it is the point at which the graph changes direction. Yeah? Also, in terms of this graph here, it will be the minimum point. Yeah, that the graph doesn't go lower than this point. And it's a minimum because it goes down and then up. Yeah? So this will be a minimum point. And if you look at it, the minimum point is H is 2 and 0, 2, 0. Yeah, so that means the H, which is the axis of symmetry, is 2. Yeah, so if I drew the axis of symmetry, it will look like this. Yeah, remember it is a line that just cuts the graph in half, right? So that's the axis of symmetry, which is 2. Yeah, remember the coordinate for the minimum point is H and K, right? So H is the axis of symmetry and K is the minimum Y value, right? So this here is the axis of symmetry, which is the line X is equal to, in this case, 2. Yeah? So that H. And this set K is 0, right? Remember, K is your minimum, the minimum or maximum point, right? So therefore, the minimum is 0, which makes sense, right? K going down, the lowest you going to is 0, then it went back up. Yeah, so there's a nice example of the coordinates at the turning point. Okay? Yeah? So that's something to remember. So this is H, K. When you put H and K together, you get the coordinates at the turning point, or the coordinate for the minimum or maximum point. Yeah, so it depends on what the axis. So let's remember when they say what is the axis of symmetry is X is equal to H, and if they say what is the minimum maximum, Y is equal to K. And if we say what is the coordinates, they will just say put H and K together. Yeah? And that's simple. That's it simple, right? So the note, when I ask a sketchy graph, which I'll show you all, the two things you'll need are the roots of the equation, which is just the coordinates at which the quadratic cuts the x-axis, like I showed you all. And the second thing is the coordinates at the minimum or maximum point, or in normal terms, the turning point. Yeah? So let's remember that. Alright, so let's continue. Alright, so let's show you some stuff here. So, yeah, about graph. Yeah? So if I were to draw like this, let's say this point was my turning point, and it was 1 and 4, right? So since it's 1, 4, remember, we know how to interpret this. This is H, and this is K, right? Since this side that this is your turning point. So that means the axis of symmetry is 1, yeah? So therefore, this cuts it in half at 1. It intercepts at 1. Yeah, so basically just drawing a vertical line cutting through 1 on the x-axis to cut it. Right, and K is here, in this case, it will be a maximum, okay? This is from, this is up here, which is 4. Yeah, so that's how it is. And as I said before, these 2 points here will be the answers you get when you solve the quadratic. the x values. Yeah, remember when you solve the quadratic, you end up with x values. And those x values are basically the point at which the graph cuts the x-axis. So this is the x-axis here. Yeah? So, same thing I showed. So let's try some questions. Alright, so you can work it while I'm doing it and see if you get the same answer. Right? So nice. So first question, I gave you this. I want to find the axis of symmetry, the maximum minimum value, the coordinates, and we want us to sketch a graph, right? So the first thing I need to do, I can't just get the axis of symmetry and all these things just so. I need to complete this, use the completion of squares method to get that. Yeah? So let's go through. So we know the form of it is ax minus h squared plus k, right? So number one, a is 2. Yeah, remember the form of the equation, so a is 2, right? So number 2, we need h. Remember, h is minus b on 2a. Yeah, so if I go back to the equation, b is 8. Yeah, remember it's ax squared plus bx plus c. So the coefficient of x squared is a, coefficient of x is b, and well, c is just a concept, right? C is the one without a letter by it, right? So in this case, b is 8, so it'll be minus b on 2, and a is 2, right? So you'll end up with minus 8 on 4, which is minus 2. Yeah? The third thing, you need to get k. I like to use the f. K is equal to f of h. F of h basically means that the value you get for h, you're just substituting it back into the equation, and you'll get what k is. Yeah? So if I do it here, y would just equal to 2, plugging in x as minus 2. So wherever I see my x, I put in minus 2. Yeah, and you can put this in a calculator or solve it, so I'll break it down here for you. So this will be 2 minus 2 by minus 2 is 4. 8 by minus 2 is minus 16. And plus 6, so this will be 8. 8 minus 16 is negative 8, and negative 8 plus 6 is equal to minus 2. Yeah, so therefore k is equal to minus 2, right? Yeah, so therefore the coordinate of the turning point or the maximum point will be h and k. So our h is minus 2 and our k is minus 2, right? Minus 2, minus 2. So now we can answer some of the questions that the graph had, right? But let's see, put it in the form, right? So let's put it in the form. So a is 2, x minus h, because h is minus 2, squared, minus 2. Yeah, so that's simplifying the inside. The minuses will come together to give me a plus. So it'll be x plus 2 squared minus 2. Yeah, so this is the completion of squares. Yeah, so now we could go back up and answer some of the questions, right? The axis of symmetry, remember that is h. So it'll be x is equal to h, so therefore x is equal to minus 2, right? The maximum minimum value, so that is your k. So in this case, y is equal to k, so y is equal to minus 2, because k is minus, right? The coordinates are the minimum maximum point. In this case, we have I think it will be a minimum. Because it will go, but when you sketch it, you'll see. I say it's a minimum. So the minimum will be minus 2, which is h, and k minus 2. Yeah? So we did this, we did this, we did this. The next thing we have to do is sketch the graph, right? So in order to sketch a graph, we need x values. Yeah? Because remember I told you, just anytime that you to sketch it, you need the coordinates or the turning point, which is the h and k, and you need the roots. Because the roots is not kind of, but it's the most important thing for sketching a quadratic. Okay, you need to know where it cuts. So all I'm going to do for this equation here is just solve it. Yeah, for the x values. So you just have to follow through with this one carefully. So we just continue with this one. So we're going to solve this equation for the values of x that we could get from it. Okay, so from here now, we'll just do it on this side. Alright, so let's write it in here. So let's divide. So now we have 2x plus 2 squared minus 2 is equal to 0. So when you're trying to solve it, you make it equal to 0 and you solve for x. Okay, so just simple form transposition. Characters the minus 2. Then divide both sides by 2 to get rid of this 2 here. So 2 divided by 2 is 1. Right, so to get rid of the square, we get square root both sides because the opposite of square is square root. So on this side, the square and the square root will cancel each other. And on this side, you will get plus or minus the square root of 1. That's the plus or minus part very important. Yeah? So just be careful. Because negative 1 by negative 1 is the same thing as 1 multiplied by 1. Yeah? So don't forget to put that plus or minus there. It's really important, alright? So now we can remove the brackets and carry across the 2. So x will equal to plus or minus 1, because the square root of 1 is 1, right? Minus 2. Okay? So with this now, we could get the 2. So it's either x is equal to plus 1 minus 2, or x is equal to the minus 1 minus 2. Remember, it's plus or minus 1, right? So solving this, x could equal to minus 1, and this one, x could equal to minus 3. Yeah? And those are your x-intercepts of the quadratic itself, right? That's as I said, when you solve it, you'll end up with the points at which it cuts, right? So that's the recap. To solve it, you just make it equal to 0. You transpose. When you get to this step here, square root both sides because the opposite of square is square root. And when you square the other side, don't forget to put the plus or minus outside. If you didn't put the plus or minus outside, you'll only end up with one of the roots. Yeah, you must put the plus or minus. Yeah. Alright, so we have our roots. We have the h and k. So now we can sketch it, right? So let's sketch it right here. Nice. So the first thing, we could put down our x-intercepts, right? So the first x-intercept is minus 3. And the second one is minus 1, right? From here, right here. Nice. The second thing we could plot is your minimum. So minus 2 and minus 2, right? So minus 2 will be here and minus 2 right here, right? So therefore the point will be right here. Okay? Then the last thing we could get from the equation is something called the y-intercept. So it's basically the point at which it cuts the y-axis, right? So in this case, you get that from right here. So C is the y-intercept. Yeah? So this sketch is basically this point here. The point at which the graph cuts the y-axis. So there's your y-axis here. Yeah, so you can get that straight from the equation, the quadratic equation, right? C, which in this case is 6. So let's go back here. So we could say this right here is 6, right? So we have all the points we need. So now we could just sketch. We could draw a line through everything. Yes. And that is a quadratic. And that is a sketch for a quadratic. You have everything in it. You have your line of symmetry with cutting it in half. You have your minimum. In this case, it's a minimum point. It doesn't go lower than that. You have your roots, and that is it. So that's the recap when you're sketching. So you have the roots. You need to get the roots. You just solve the equation. Second thing you need to get is the turning points, which is your h and k. And the third thing is your y-intercept, which is just c from the equation. Yeah? When I say c from the equation, it's just remember it's ax squared plus bx plus c, right? So this here will be c. Okay? And that's the question right there. Yeah.